Hey guys, we're going to start working through the first spring semester exam review. Okay, it's long, so just buckle in. Alright, number one, convert to log form. So this is an exponential form, wants me to convert to log form. To convert to log form, we start by actually writing log, and then we put the base. So the base here is 3, because that's the only thing that has a power. So the base is 3. Then you take the output, and that becomes your input, so you put 81 right here, is equal to your exponent, which is 4. Bam, that's all you got to do. Okay, this problem. What is the solution of 7 raised to the x is equal to 49 raised to the 4th? Alright, the easiest way to do this problem, guys, is with a calculator. Alright? So, this is how I'd, this is how I'd go about approaching this problem. I'd realize that x is in the exponent position. So I want to change to log form to get x out of the exponent position. Okay? So first off, I have to make sure the base is by itself. It is. There's nothing adding, subtracting, multiplying, or dividing to the base of 7. So I say log, I keep the same base, so base 7 of, and this side becomes my input, so 49 to the 4th, is equal to my output, which is just the exponent, which is just x. Alright? So now the rest of this problem can be done in your handy dandy calculator. Alright? You guys should hit math, scroll down to log base, or scroll up really. I have to use my calculator's, my calculator doesn't have that ability, so I have to do it slightly differently than you do. Alright, but you should get the same number I get. And that's 8. So x equals 8. Okay, moving on. Number 3. The graph of f of x equals the natural log of x is shown below. What is the equation of the vertical asymptote? Guys, the vertical asymptote is at x equals 0 unless my graph has shifted left or right. Well, is there any transformations in this thing right here? No. So it's just x equals 0. Alright, number 4. Describe how y equals log base 2 of x plus 2 minus 4 relates to the parent function of log base 2 of x. Okay, it went to the left 2 and down 4. So you just write left 2, down 4. Because the plus 2 is inside the parentheses with x, so plus 2 means left 2. It's opposite of what you think. And minus 4 is outside the function, so that just means down 4. Okay? Let's go back up to problem number 5. Convert to exponential form. Okay, so it's in log form right now. I just want to convert to exponential form. It doesn't say solve, it just says convert. So the base is your base, so you say 2. You take this side, it becomes your exponent, is equal to what's inside the log, which is 4x minus 3. And that's all we got to do. Alright, what is the domain of the function of log base 3 of x? Okay, guys, you should remember that log functions, assuming there are no transformations, look like this, and they have a vertical asymptote at x equals 0. Okay? So, then, my domain would just be parenthesis 0 to infinity. And that would be it, because we never actually touch 0, so that's why it gets a parenthesis. Alright? Number 7. What is the domain of the inverse of the function? What is the domain of the inverse of log base 3 of x? Oh, okay, guys. So what was the range? Did y'all just look at that graph? What was the range of that graph I just had drawn? Negative infinity, positive infinity, right? So that would be the domain of the inverse. Okay. Problem number 8. Write the equation that matches the following growth example. All right. Carlos has $300 and is investing it at a 2% interest rate. Easy. So that's how you do. You just say 300 times 1.02 raised to the t. Alright, because the reason it's 1.02 is because you remember it's 1 plus r. You might remember this formula. Okay, p times 1 plus r raised to the t. And r in this case is your interest rate in decimal format. So 2% in decimal format is 0.02. You add that to 1, you get 1.02. Okay, number 9. A mathlete solved, he got how reasonable are his solutions. Okay, you should remember the key word here is reasonable. Reasonable does not mean correct. It means do they make sense. So in other words, if you were to plug them in, would they cause any errors? Well, plug them in. Negative 1 plus 3, negative 1 plus 5. This would give you log base 2 of 2 plus log base 2 of 4. Is there any error in that? No, that's fine. But what if you plugged in negative 7? Negative 7 plus 3 is a negative 4, so you wouldn't get 2 here. You'd get negative 4. Can you take the log of a negative? No. So that doesn't work. So -7 is not reasonable. We would call that an extraneous solution. Just remember extra, okay? But -1 is reasonable. It's good. That's a check mark. Okay? Alright, moving on. Number 10, solve the natural log of x plus 6 is equal to 5. Okay, so first off, you have to remember something. What is the base of a natural log? It's e, that's right. So first off, my x is trapped in a log. Okay, it's a natural log, and I'm still trapped in a log. So I need to change from log form to exponential form. Okay, so I take the base, I raise it to the other side, which is 5, and I set it equal to the inside, which is x plus 6. Now you just got to finish solving for x, so you need to subtract 6 over to the other side. So now we have e to the 5th minus 6 is equal to x. And we are done. That's all that you'd have to do on this problem. You might want to type in the calculator and get an approximate answer. You don't have to. I know the test is multiple choice. I don't remember exactly if how it phrases this question. So e to the 5th minus 6. So then 142.41, if you want to get an approximate solution, you could say x is approximately 142.41. Okay? Alright, moving on to number 11. Solve log of 7x equals 3. Okay, so once again, x is trapped by the log. Alright. So what we do is we'd say take the base, which should be 10. We raise it to the other side. And we set that equal to the inside, 7x. So then, to finish solving for x, you just divide both sides by 7. And so we get 10 to the third divided by 7. I'm pretty sure 10 to the third is 1,000. In fact, I know it is. Divide that by 7. And we get 142.86. So x is approximately, this is problem number 11, 142.86. Okay? Number 12, it says, given that f of x equals log base b of x minus 1, what function is the inverse of f of x? Okay, so how do we find the inverse? We switch x and y. So this becomes x, this becomes y. And now I solve for y all over again. So currently I have x equals log base b of x minus 1. So I need to change from, y minus 1. My apologies, that's a y. Y minus 1, okay? So y is trapped by the log, so I need to get it out of log form. So I take the base b, I raise it to the other side, which is x. I set equal to y minus 1. So then my last step would be just to add 1. So I get b raised to the x plus 1 is equal to y. And bam, that would be the inverse. Alright. Moving on, problem number 13. Give the minimum value of f of x equal to log base 2 of x for the given interval of x, 2 to 7. So this is the interval. This is your x's, okay? You want to find the lowest y value that happens when you plug these in. Our calculator can do that for us. Again, I'm going to go to y equals. I suggest you guys go to y equals and then go to math and scroll up to log base. I have to use my calculator's change of base formula ability. Well, actually, it's just understanding the log properties. Okay, but you guys can just use log base instead of typing this. I'm going to go to the table, and I'm going to look through these x values from 2 to 7. And now, so from 2 to 7, I care about the lowest, because that's for the minimum. So I care about the lowest y value that's happening between x values of 2 to 7. So that would just be 1. So it is 1. And there we go. Okay, next problem. Number 14. Sandy drops a ball from a height of 24 meters. Its height on each successive bounce is 1/4 of its height on the previous bounce. Which exponential function best models its height on the nth bounce? Okay. So, guys, you start off with your starting amount, which is 24. Okay. You multiply that by what you're changing by, which is 1/4 each time. And then it says on the nth bounce, so we just raise it to the n. Okay. And that's it. That's all I have to do for 14. That's it. Okay. Number 15. The sum of two polynomial expressions is... Oh, I went too far. The sum of two polynomial expressions is 6x to the 4th plus 3x cubed plus... Okay, you can read that. One of the polynomials is this. What is the other polynomial? So in other words, I added this polynomial with some other polynomial, and I got this polynomial. Okay? So, guys, just think through this part. If you have 2x to the 4th, and you want 6x to the 4th, how many more x's to the 4th do you need? 4. So 4x to the 4th. Alright? You have 2x cubed. You want 3x cubed. How many more x cubes do you need? 1. So I just say plus x cubed. You have 0x squares. You want 2x squares. How many more x squares do you need? 2. You have 5x's, but you only need 4x's. So then what does this polynomial need to have? A negative x. This is a negative 7, but you need a positive 1. So you need to have another positive 8. And there you go. That's the other polynomial you need. All right. Moving on. Problem number 16. If I can get over there. Problem number 16. Multiply the polynomial shown and simplify. Okay. Remember, when we're multiplying stuff, we just do first a second, first a third, second a first, second a second, second a third. So x times x squared is x cubed. X times negative 2x is negative 2x squared. X times 8 is 8x. And then I do 7 times x squared, which is 7x squared. And then I do 7 times negative 2x, which is negative 14x. And then I do 7 times 8, which is 56. Alright, now I just put like terms together, so that gives me 2x cubed. It gives me x cubed. I have a negative 2x squared, a positive 7x squared, that gives me 5x squared. I have 8x, negative 14x, that gives me negative 6x. And then plus 56. Bam, I'm done. Okay, moving on, number 17. Okay, number 17, factor x cubed minus 216. Alright, this is the difference of cubes. You need to remember this formula. A minus b times a squared plus ab, 2ab, sorry, plus b squared. Okay, so I lied. Sorry, I said 2ab there. That was just kidding. Just kidding. It's just ab. I was right when I said just ab. I don't know why my brain wanted to put a 2 there. Alright, so plus, that does not look like a plus. Plus ab, okay. So now what you have to do is you have to look at this and say, okay, so what am I cubing to get x cubed? Just x. What am I cubing to get 216? I actually don't know. So let's use my calculator to figure out. Because if it's not a nice whole number, then you can't even do what I'm trying to get you to do. 216 raised to the 1/3. So 6. Okay, so I'm cubing 6. 6 raised to the 3rd power is 216. Okay? So now I'm just going to plug these in for a and b. X is a, 6 is b. So I'm going to say x minus 6 times x squared plus 6x plus 6 squared, which is just 36. Bam. I'm done. That's all I have to do. That's all I can factor. Alright, moving on to number 18. Divide that by x plus 2 using synthetic or long division. I'm going to use synthetic. Synthetic is where we have the upside down long division box. What goes in here is you take what you're dividing by, x plus 2, you set that equal to 0, solve for x, so x equals negative 2, okay, because that's a 0. So that's what you're going to put next to your synthetic division box. Then you write down the coefficients in order, starting with your coefficient of your highest power of x. So I went 1, 4, 1, negative 6. Then you carry down the first number, multiply, add, multiply, which is negative 3, add, multiply, negative 2 times negative 3 is 6. Now you add, which is 0. So the last number is always your remainder, so I don't have a remainder. This is your constant, this is your coefficient on x, this is your coefficient on x squared. So we get 1x squared plus 2x minus 3. That is your quotient. Okay, moving on. Problem number 19. List all the factors in this polynomial through graphing. Okay, so pull out a calculator, go to y equals, click clear, type this guy in, so x raised to the 3rd plus 2x squared minus x plus 28. Hit graph. Okay. Alright, I guarantee you it's cross the graph more times. We can't see it, so I'm going to go to zoom 0, which is also called zoom fit. I can tell you guys it should have crossed the graph about 3 times because this has the highest power of 3. And I've only seen it cross 1 time, so I can just tell you that I should see a couple other Okay, that didn't work. Let's go back to Zoom 6. Sometimes when you're playing around trying to graph on a calculator, it's just what you have to do. Let's try doing Zoom out and seeing what that shows me. Did I type this in right? I'm not seeing anything here. That doesn't look right. Why am I only seeing it cross once? Okay, I'm going to pause this video until I figure this out. Hold on. Okay, I'm going to mention this in class because I just realized there's a problem. Alright? Here's the problem with this situation. You cannot list all the factors by graphing. Okay? You can do it another way, but since this problem specifically says by graphing, you cannot do it through graphing. So here's what we're going to do, and I'm going to mention it in class. But here's what we're going to do. We're going to get rid of this plus 28. Okay? So this is our new guy. Okay, so we're just going to type this guy into our calculator. Okay? So we're going to get rid of the plus 28. Okay? Delete, delete, delete. Alright, now we're going to hit graph. Okay, so now what we have is we need to see where it's crossing the x-axis. So first off, we see if we can't just see it on the table real fast and easy. Okay? So, why can I not find this one? Okay, so we can't find it on the table real nice and easy. Alright? We only found one of the places where it was crossing. Because in order for it to be crossing the x-axis, what does y have to be? Y has to be 0, right? So we're clearly crossing when x is 0, y is 0. So we could say that one of my answers, I'll change it to a factor in a second, is x equals 0. Okay? When x is 0, y is 0. The problem is I need to find two other places, because you can see this guy touches the x-axis 3 times. Here, here, and here. Okay? So what we're going to have to use our calculator's zero ability. Okay? We've done this before in class. So left bound, right bound. Now we're going to move it to being to the right of the place where we think it crosses the x-axis. We hit yes. Okay, that's not what I wanted. Maybe it only crossed. You know what I think I'm going to do is I think I'm just going to tell you I'll scrap this problem. I don't think this problem is working out how I wanted it to work out. Which means I'm going to have to try to go into this video later and edit it. No, it is crossing twice. I don't know why it gave me 0. It's crossing right here. Oh, I'm dumb. I'm dumb. So we go back to that. We go to 0. Left bound. Okay, where's my cursor? Okay, my cursor is right here. But I want to move it to where it's on the left side of this crossing right here. Alright, so I move it. I press enter. Move it to where it's press enter on guess. So we also cross at point 41. This is a stupid problem. I think we're giving you much easier numbers than you're getting right now on the actual test. Alright? And then we have to do it one more time for this 0 all the way over here. So second trace, 0. Now we need to move the cursor. Oh, it's not even moving. Okay. This is being a pain. There we go. Now we've got it moving. Okay. Almost there. Okay. So we're to the left of this x-intercept, which is also called a 0. So now I want to move to the right bound. Now I'm to the right of it. Press enter on guess. Negative 2.41. So x equals negative 2.41. So these are my 3 solutions. These are my 3 roots. In other words, it crosses the x-axis 3 times at these places. How do I turn these into factors? Well, guys, basically you move the numbers back over to the other side. Okay, so x equals 0. Well, I can't move 0 over. 0. So that gives me a factor of x. Then this next factor, if I was to move 0.41 over, it would become x minus 0.41. So x minus 0.41. And then the last one would be if I move negative 2.41 over, it would become x plus 2.41. And there we go. Alright, so that would be the factors of this polynomial. Alright, sorry that was a confusing problem. Alright, moving on to problem 20. Describe the changes of the graph below, g of x, from the graph. So guys, all this guy's saying is it was a cube root, and it still is cube root, but it's just simply saying how have I adjusted it from the parent function of the cube root. So you should remember that the parent function of the cube root looks something like this. Okay? So we should be crossing through at 0, 0, but now I'm clearly crossing through at, okay, clearly is a rough term here. I'm going to say that's a negative 2. I'm just going to assume these units go by 1 because I can't really see that very well. So 1, negative 2. So basically I shifted to the right one. So how do I show that I shifted to the right one? I do x minus 1. And then how do I say I shifted down 2? This is a minus 1 right here. How do I say I shifted down 2? I put minus 2. And bam. There we go. Okay. Number 21. Solve the cube root of 2x plus 3 minus 3 is equal to 0. Okay, to solve cube roots, you've got to get x by itself. Alright, but before I can get x by itself, I have to get rid of this cube root. Before I can get the cube root gone, I have to get the cube root by itself. So basically what you need to do is add 3 first. So now we have the cube root of 2x plus 3 equals 3. Now I can raise both sides to the third power, because that's the opposite of a cube root. Okay? So, gone. Gone. So now I get 2x plus 3 is equal to 27, because that's 3 to the third power is 27. Subtract 3, divide by 2, and I will get x equals 12. Because you subtract 3, it gives you 24. 24 divided by 2 is 12. So, bam, there you go. X equals 12. Okay? Number 22, solve. Okay, so this is solving, and it gives us a bunch of fractions. What is step 1 when solving fractions? Factor everything. So we get 1 over 2x plus 2. I can factor that denominator. 2x and 2 both have a 2 in common, so I can factor it down to being 2 times x plus 1 minus 1 over x minus 1 equals, okay, 5 over, okay, x squared minus 1 can be factored by tic-tac-toe. So we draw a tic-tac-toe box. This is x squared. This is negative 1. Multiply. That gives me negative x squared. So now we need to look for two numbers that multiply to negative x squared but add to 0x. X and negative x, absolutely. X squared and x have an x in common. X squared and negative x have an x in common. X times 1 is x. X times negative 1. Go across, go across. So I get x plus 1, x minus 1. So now what I'm looking at is simply what do these denominators need to have that they don't have right now? Well, this denominator doesn't have an x minus 1 that both of these denominators do have. So x minus 1 over x minus 1. Okay. What does this denominator need? It needs a 2 and an x plus 1. Okay. 2 and an x plus 1. That 2 is on the outside of the parentheses. I just wrote this weird. 2 x plus 1. And then this guy just needs a 2. Okay, now that all my denominators would be the same, since I'm solving, this only works when solving, I can cancel out all my denominators. So now let's multiply my numerator. X minus 1 times 1 is just x minus 1. Minus 1 times 2 times x plus 1, which will give me 1 times 2, which is 2. 2 times x, which is 2x. Minus 2 times 1, which is just 2, is equal to 10. So now I need to solve for x. X minus 2x is negative x. Negative 1 minus 2 is negative 3 is equal to 10. Add 3, that gives you 13. So negative x is equal to 13. Divide both sides by negative 1. So x equals negative 13. So bam. X is equal to a negative 13. Alright, there you go. Alright, next problem. Problem 23. Let me see if I can get over there. It's being a pain. There we go. Problem 23. It says, list the range of the function graph below. Okay, range is lowest y value to highest y value. I clearly, excuse me. Excuse me. I clearly have a horizontal asymptote happening right here because this is a rational function, and I know a rational function has a horizontal asymptote. And this one seems to be located at y equals 3. Okay. So then my range is negative infinity to 3, both with parentheses because I don't ever actually touch the horizontal asymptote, and 3 to infinity. Okay. Moving on, 24. List the minimum and maximum of 1 over x and the intervals from negative 4 to 8. So once again, guys, these are x values. Alright, so I'm going to go to my calculator, and turn it on. I'm going to go to y equals, clear this junk out, and do 1 divided by x. Then I'm going to go to the table. I'm going to look at x values from -4 to 8, and I want to find my lowest y value and my highest y value. Okay? This problem is tricky. Think about it very carefully. Alright? So, when you're looking at all these, what's your lowest y value? Okay, when you're looking at all these, which one was the lowest? Really take your time to think about it. Which one was the lowest y value from -4 to 8? What was the lowest y value that it gave you? -1. That's right. Some of you might have been tempted to say -0.5 or -0.33. But think about that in terms of being in debt. Are you more in debt if you owe someone 33 cents, or are you more in debt if you owe someone a whole dollar? That's right, a whole dollar. So the minimum is -1. So what was the maximum? What was the largest x value we saw? What was the largest y value we saw? Hopefully you're already like, oh, it was 1. 1 was my lowest. My highest. Sorry. And that would be correct. Okay. Moving on to problem 25. Add and simplify completely. Okay, in order to add fractions, they have to have the same denominator. So I start by factoring. Okay. X squared plus 4x plus 4, I factor through tic-tac-toe. So x squared, 4x squared. Okay. That gives me 4x. Alright, so what are two numbers that multiply to 4x but add to 4x? Hopefully you're like, oh yeah, 2x and 2x. X squared and 2x, what do they have in common? X. X squared and 2x, what do they have in common? X. X times what is 2x? 2. X times what is 2x? 2. Go across, go across. So this guy is now x plus 2 times x plus 2. There's a cheat to this problem. Look at this parenthesis you have on the left side. I'm sorry, I said that wrong. Look at this fraction you have on the left side. Here, let me rewrite it just so it's a little bit clearer. You have x plus 2 in the numerator over x plus 2 times x plus 2 plus 2 over x plus 2. Guys, there's a cheat to this problem. It'll make your life easier if you notice this cheat. Look at this fraction. Ignore this fraction. Look at just this fraction. Can you cancel anything out on just... If you ignore this fraction, you can still cancel stuff out on one fraction. You just can't do it across fractions if they don't have the same denominator. Okay? But this guy is just its own fraction. Can you cancel anything out? Well, yes, this whole x plus 2 can cancel out with one of these x plus 2's. So now I have 1 over x plus 2 plus 2 over x plus 2. Now look, are the denominators the same? Yes. So what is 1 plus 2? 3. So you get 3 over x plus 2. And that's as far as you have to go. You're done. Alright. Moving on to problem 26. So I can figure out where my guy is. There we go. What is the inverse of f for the function y equals 1/2 x plus 2 cubed? Okay, to find inverses, the first thing you do is switch x and y. So now I have x equals 1/2 times y plus 2 raised to the third power. Okay, to get the y by itself, I have to get the cube by itself first. So I got to divide both sides by 1/2. Well, dividing by 1/2 is the same thing as multiplying by the reciprocal of 1/2, which is 2 over 1, which is 2. So this really gives me 2x is equal to y plus 2 cubed. Okay, how do I get rid of a cube? I raise it to the 1/3 power, or I take the cube root, because those are the same things. So I get the cube root of 2x. Sorry, I'm writing all over the place. I'm trying out of space. The cube root of 2x is equal to y plus 2. So then the last thing I need to do is subtract 2 over. So I have the cube root of 2x minus 2 is equal to y. And there we go. Okay. Next problem, problem 27. What is the graph of y equals x minus 1 cubed minus 2? Oh, hey, they even gave us some answer choices. So I went right 1, down 2. So look at these tick marks. Be very aware, these tick marks are going over by 2's each time. So you want to go right 1. So that means you only go right a half, and then you go down a whole tick mark. So it's got to be B. B is my answer choice. Perfect. I went right 1. You can tell that's only half the tick mark. And then I went down a whole tick mark. So that puts me right there, which is right 1, down 2. Okay? Moving on to problem 28, which is up here, I believe. The graph represents the function. I'm struggling. The graph represents this function, okay, right here. What is the range of the inverse? Okay, Take a moment to figure out this guy's domain. The domain of the original is the range of the inverse. So this guy's domain is all real numbers. So then, what is the range of this guy? That's right. The inverse, the range of the inverse is all real numbers. Okay? Problem 29. Solve 2x plus 8 raised to the 1/3 power. Stop. 2x plus 8 is equal to 1/3 power is equal to 4. Okay, so where is x? It's trapped by the 1/3 power. So step 1 is to get rid of the 1/3 power by raising both sides to the 3rd power. Okay, so that cancels that out with that. So I get 2x plus 8 is equal to, what is 4 to the 3rd power? It is 64. So then I need to subtract 8 and divide by 2. So I'm going to get x is equal to, well, 64 minus 8 is 56. 56 divided by 2 is 28, I think, but I want to double check before I say that, before I write that. 56 divided by 2 is 28. Very good. So x equals 28. All right. Whew. Last but not least is problem 30. Divide and simplify. Okay, before we can do anything with fractions, step 1 is to factor everything. X squared minus 25. We can factor that through tic-tac-toe. X squared. Negative 25. Negative 25x squared. Alright, the middle term is 0x. Two numbers that multiply negative 25x squared but add 0x. 5x and negative 5x. Okay, x squared and 5x have an x in common. X squared and negative 5x have an x in common. X times 5 is 5x. X times negative 5. So this guy is now 10x over x plus 5 times x minus 5. Okay, divided by. Okay, now we need to factor this guy, so it's going to be 5 over. Okay, so we say x squared positive 15, 15x squared. Alright, this is going to be negative 8x. Okay, so two numbers that multiply to 15x squared but add negative 8x are negative 5x and negative 3x. What does x squared and negative 5x have in common? X. What does x squared and negative 3x have in common? X. X times what is negative 5x? Negative 5. X times what is negative 3x? Negative 3. So, x minus 3, x minus 5. Whew, I'm running out of room here. Okay, so you're going to erase this so I have a little bit of room to write up here. Alright, when we're dividing fractions, some of you guys prefer to use the butterfly method. That's fine. I prefer to use the keep, change, flip. So we're going to keep this left side. So I'm going to say 10x over x plus 5, x minus 5. Okay, so that's 10x over x plus 5, x minus 5 times x minus 3 times x minus 5 over 5. Okay, so since now these are fractions are multiplying, you basically just have one big fraction with everything on top multiplying with everything on bottom. So 10 and 5 can reduce to where the 10 becomes a 2, and the x minus 5s can cancel. So you end up with 2 times x minus 3 over x plus 5. And that's all she wrote. Whew, guys, this was lengthy. Alright? If you made it way all through this, I'm impressed. I'm proud. Remember, you can use a one-sided cheat sheet that's handwritten. You know, so really watch this video. Focus on the ones that you just don't know. Focus on the ones you want to get right. Okay? I wish you guys the best of luck. Please let me know what questions you have. Okay, thanks.